Hello everyone, I'm Juliana Nock from the National Institute for Space Research. I will present the paper Climate Precipitation Prediction with Uncertainty Quantification by Self-Configuring Neural Network. I will talk about our study in 4 sections. First of all, I will begin by talking about our motivation for this work. Then, I will present the methodology where the goal is to configure the neural network parameters by solving an optimization problem with multi-particle collision algorithm, MPCA. After that, I will talk about the application used in this work, climate precipitation prediction. Finally, I will show the results and conclusions. The motivation for this paper comes from this article, Two Geoscience Applications by Optimal Neural Network Architecture, where the climate seasonal precipitation prediction is made by neural networks. However, how can we find a good architecture or topology for a neural network? The standard approach is employed, an empirical process where some topologies are defined and tested by changing the parameters of the neural network, and the process is restarted. But this method is a slow process because it can require a long time for an expert. But here we are going to address the uncertainty quantification. So, how can we find a good architecture for a neural network? This strategy can be considered as an optimization problem where each point in the search space represents a neural network with different topologies, where the goal is to find the best set of the neural network parameters to optimize the objective function. Here is an example of a multi-layer perceptron model with an input layer, a hide layer, and the output layer, where we'll have two outputs. First, the precipitation prediction, and second, the uncertainty quantification by neural prediction. The objective function used in the MPCA algorithm was implemented to weight the training and the generalization mean square error and a penalty term. The function is given by equation 1. The mean square error metric is adopted. This criterion refers to ability of the neural network to identify similar patterns. And the uncertainty was calculated from the variance of average error obtained from the difference between the neural network output and the targeting value. Here, we use the multi-particle collision algorithm, MPCA, for configuration the topology of the multi-layer perceptron network. The MPCA was introduced by Eduardo Luz and José Carlos Besseneri and Haroldo Campos Velho. The MPCA has been used successfully in several optimization problems, such as identification of atmospheric temperature profile, climate prediction, solution of inversion problem, and the others applications. The neural network model was applied to predict the monthly climate for the precipitation field. Our study is focused on two approaches. Firstly, to produce a monthly prediction for precipitation by a neural network. Secondly, the neural network output is also designed to estimate the uncertain quantification by neural prediction. For the climate prediction of precipitation using neural network, different datasets were collected from reanalysis and the Global Precipitation Climatology Project Monthly Precipitation Dataset, GPCP. The datasets are monthly data from January 1990 up to December 2018. The input variables are zonal and meridional winds at two levels, air temperature, specific humidity at 850 hectopascals, and the pressure surface from reanalysis data. And the reference values for training are GPCP. The training data was formed with data from January 1990 up to December 2001. The period from January 2002 up to December 2017 was used for the test, and the prediction subset corresponds to the period from January 2018 up to December 2018. The neural network model has 9 variables as initial condition. After training, it will produce two outputs: the precipitation prediction and the prediction certain quantification. And which parameters should be specified in neural network? The number of layers. How many layers should be in the neural networks? For this parameter, we can have up to 3 hidden layers. The number of neurons. How many neurons should be in each hidden layers? For this parameter, we can have up to 40 neurons. Learning ratio, which is between 0 to 1. Moment ratio, which is between 0 to 0.5. And the type of activation function, which can be sigmoid, hyperbolic tangent, or Gaussian. This figure shows an example of a climate prediction process on a seasonal scale. In this example, the neural network model has the autumn season as input, and the output will be the precipitation prediction for the next season, which in this case will be in winter. The climate prediction problem was applied in the Northeast region of Brazil. The considered region is illustrated in highlight. The best parameter configuration for a neural network defined from the MPCA were one hidden layer with 12 neurons, the learning ratio 0.57, moment ratio 0.65, and the activation function is logistic sigmoid. The neural network model was applied to predict the monthly climate for the precipitation field. As I said before, the goal of this paper is focused on two approaches. First, to produce a monthly prediction for precipitation by a neural network. Second, the neural network output is also designed to estimate the uncertain quantification for neural prediction. The results presented here show the behavior of the neural network as a predictor model of the precipitation for the Northeast region in January of 2018. Figure A shows the observed precipitation by GPCP. Figure B shows the results of the precipitation prediction by the neural network model. And figure C is the estimated variance. In January, the neural network model was able to catch the patterns for precipitation to the region under analysis. Looking at the variance map, the lower the variance, the better the prediction. Here, the result of the prediction is for March of 2018, where the figure A shows the observed precipitation by GPCP. Figure B presents the result of the precipitation prediction by the neural network model, and figure C is the estimated variance. These results shows that a neural network had a pattern very similar to the observed data, which can be noticed in the variance map. You can see that the neural network predicted the lower precipitation in South region and the more precipitation in Eastern region. Here, the results of the prediction in July of 2018, where the figure A shows the observed precipitation by GPCP, figure B presents the result of the precipitation prediction by the neural network model, and figure C is the estimated variance. The poorest prediction was verified in the south of the region. See the variance map. But we should not only evaluate the field for the prediction, but how good the prediction was, where the variance is lower. Finally, the result of prediction in December of 2018. And here we can see that the prediction result was better compared to the other months. As I said before, the poorest prediction was verified in the south of the region. More studies needed to carry out for a better understanding of such behavior, and additional information is necessary to include in the model. The MPCA approach does not require an expert to the task for neural network configuration. The neural network model can be implemented for operational centers and research institutes with much lower computational effort. The self-configuring formulation allows the application of a neural network technique for a large community. Optimal neural network topology is a relevant issue for real applications. Brazil is a country with different climate regime, like tropical zone, equatorial zone, and subtropical zone. The variable precipitation has a high degree of difficulty to be predicted. So, thank you very much for your attention. The paper has been co-authored by Renier Hernandes Torres and Haroldo Campos Velho.